She grew up on a cattle farm in South Dakota, and she made her way in 2000. She received a BA from Harvard University in anthropology with a specialization in archaeology. In 2012, she received her PhD at Texas A&M University in anthropology. Her work history includes that she's conducted research or worked on CRM projects all over the United States, Northeastern United States, Northern Plains, Texas, and the Southeastern US. Her primary areas of interest are peopling of the Americas, climate change during the terminal Pleistocene period, coastal site preservation, and human adaptation to major climate change. In 2011, my wife and I were lucky to work at the Topper site in South Carolina. We were sitting at a picnic table, and I was discussing an article that I had read about the Continental Shelf Project, which is the ship that was studying the last glacial maximum coastlines off the coast of Western Florida, and it included 500 potential targets for future research. As we're sitting there at the picnic table, and I was discussing this with my new friends, a nice young lady with a great smile turned around and said, "I was on that ship." So I introduce to you, ladies and gentlemen, Dr. Jessi Halligan. Welcome.
Hi, everyone. Thanks for inviting me. Thanks for having me. I am going to be giving a little bit of a summary of research I've been doing, not offshore. I haven't been doing that much offshore in recent years, though a few of my students have been. They've been doing this really cool research lately with something called a sub-bottom profiler. It's a type of sonar and that is commonly used for offshore surveys of all kinds, oil and natural gas, everything, because it gives you a picture of the ocean in the bottom. And they think they figured out a way to make it actually show individual artifacts. There's basically a harmonic resonance, which if any of you guys are any kind of radar sound people at all, you would probably understand what that means more than I do. But they've actually found a whole bunch of archaeological sites in the Gulf of Mexico by running their sonar and looking where they are seeing those resonances in the data. So I can talk to you about that more later. But mostly I'm going to get into my research at the Page-Ladson site and some of the big picture things that Page-Ladson means for our people understanding the peopling of the Americas. So I'm going to kind of start in about the archaeology of the last ice age and then narrow into the Page-Ladson site as we go along. So since the very first people arrived in the New World, there's been some really big questions about who they were and where they came from. And I think that probably is for the same question that the very first people, they were probably asking their parents, hey, when did we get here? Where did we come from? Who are we, right? But more recent research has given us kind of a major outline of three main places that the peopling of Americas could have come from. The first people could have come from Asia over land, from Asia over water, or from Europe over water. And this has led to some refinements of these models over recent years. They're really a nice setup for archaeologists because there's different expectations that are generated based on when the earliest sites date to, based on ancient DNA, based on artifact assemblages. And I want to say this isn't the only thing Paleo-Indian archaeologists care about. This is something we get tarred with the feather of. All we care about is the earliest and oldest. We do care a lot about their early lifeways, what they did, how they lived, how their lifeways changed over time, how over space, what they did at any given site. But these are our big early questions, and those are what I'm going to focus on mostly today. When did people get here and where did they come from? So as we all know, the first peoples in the Americas got here sometime during the last ice age. When and where is a big open question, but the ice age was when the human species in general really spread out throughout the entire world, right? Prior to the Ice Age, all hominids were found in Africa. The Ice Age started around 2.6 million years ago, and most of the evolution of Homo sapiens occurred in Africa during that time period. They spread to Australia by 15,000 years ago, And they were in the Americas by at least 15,000 years ago. So 50,000 for Australia, much, much later for the Americas. But they had spread throughout the entire world. Everywhere people live today, they lived by the end of the last ice age, by the end of 11,500 years ago. So these routes, and I'm going to be showing you this particular slide, have been set up a few different testable expectations. So based on when we know people actually could have come to the New World, based on sea level, based on technology, based on when humans were in, we've kind of set up these three kind of opposing hypotheses: that they came across land either really a long time before 20,000 years ago or after 15,000 years ago, that they came by boat anytime after 17,000 years ago, or that they came from Europe sometime prior to 20,000 years ago. And I'm going to spend some time going into why those are our competing models in a little bit. So first of all, I'm going to keep using this term, terminal Pleistocene, and I'm going to keep saying Paleo-Indian. So I can't train myself out of those words, so I'm just going to define them for you. So terminal Pleistocene, what I mean by that is the latest part of the last ice age. So technically, that's the time from the last glacial maximum, which is the really fancy geology term for when the glaciers were last at their maximum extent, hence last glacial maximum. And that was about 21,000 years ago. At about 21,000 years ago, the ice started melting away, the glaciers started retreating, and by 11,500 years ago, all of those big environmental changes, they weren't finished with, but they were to a point that they're that we really called it a new geologic era. We call it the Holocene, which starts at 11,500 years ago. And for those of you who are used to dealing with dates from radiocarbon dates that aren't calibrated, that's about 18,000 to 10,000 radiocarbon years ago. But in real years ago, that's 21,000, 11,500. And for archaeologists who work in the New World, that is the Paleo-Indian period. It's basically the Pleistocene or the upper Paleolithic cultures in the Americas. They're all called Paleo-Indian. And the early end of that is the question marks I'm going to be talking to you about today. But that ends at about 11,500 years ago too. And for those of you who've done a lot of archaeology or have, spent a lot of time collecting artifacts, you'll know that there's a big change in the technology and where sites are and everything around 11,500 years ago. So it's not just an arbitrary archaeologists say this is when things end. There's some big culture changes that occur at that time. So you're probably wondering, if archaeologists have been researching for 50, 100, 150, 15,000 years when people got here and how they got here, why we're so bad at answering those questions, like why we don't know yet. But there are some real reasons why it's hard to answer. So I've already shown you the picture of how Florida was immensely different 21,000 years ago. The continental shelves were almost totally exposed when the massive amounts of glaciers were covering the North Pole. And the South Pole, when there were major glaciers everywhere. Sea levels were about 350 feet lower than they are now. And so as those glaciers melted, they scoured stream beds. They changed what was massive amounts of ice into dry land. Well, first into rivers and lakes, and then into dry land. They just changed everything. And part of that change was all of the plants and animal species really shifted around. A whole bunch of species went extinct, like all of those there on that bottom picture: North American lions, horses, mammoths, mastodons, various types of rhinoceroses, and also dozens and dozens of small species like insects and rodents and things like that. And part of the thing that I really liked this cartoon, because it shows you how much ice there was during the last glacial maximum at the end of the last ice age. Montreal had 3,300 meters of ice on top of where the city is now. So you can see the skyline and then how much ice that is. So that really represents how much the world changed. And the process of that melting, it didn't just melt and then magically go into the oceans. It had to scour all the landscape between where it was melting and where it ended up. You all probably have, seen what floods can do in your life if you've ever turned on a TV in the summer. So you know that had a huge impact on the world. So to answer questions about early people, or really any archaeological questions, we have some really well-defined rules for a site to help us see, okay, will this site help us answer questions? And these were defined by Vance Haynes, who was one of the very first geoarchaeologists in the US. And he really laid out some really good rules, right? If you want to say that you have a site that's going to answer questions, you have to have a skeleton or artifacts. Like a human skeleton obviously lets you know it's an archaeological site, right? But you also have to have artifacts that are clearly made by people. They have to be in undisturbed geological context, and the association between those artifacts and those geological deposits has to be clear. And ideally, those stratigraphy and artifacts have to be datable. Datable meaning radiocarbon dating, but also datable, like if you have mastodon bones with a spear point in it, you can say that those mastodon bones date to, or that the spear point dates to when a mastodon was alive, right? So right here, this is a picture from the Page-Ladson site from our younger excavation areas. This is a Bullen point, which I don't know if you all call them Bullens up in Georgia, but it's an early archaic notched point. You might, I don't know what you all might call those, but we have them up there in Florida, pretty much everywhere. If you dig enough holes, you're going to find one of these points. And around it, so we have this Bullen point, and then we have all these little black specks that probably look like nothing to you, but what they are is burned wood. So we were able to get 7 or 8 radiocarbon dates on this Bullen point right there to really help us try to nail down how old they are. But we were only able to do that because we had really good preservation of the wood in that stratum. In general, Bullen sites aren't datable. Probably you have the same problem up in Georgia. Most early archaic sites, there's no wood preservation. There's nothing except artifacts and some sand, right? So this is a really important thing about these underwater sites in the Osceola Basin where I work. So I want to step back though and put this into a big picture context for you. As I said, archaeologists have been trying to figure out when native peoples came to the New World for as long as we've been doing archaeology in the New World, right? And prior to, in the 18th, 19th, and 20th century, we didn't think that indigenous people had been here for very long. We thought they had come maybe not any earlier than biblical peoples. Sorry, my border collie's gonna bark every once in a while. They might not have showed up any earlier than about 6,000 years ago. And there was a guy at the Smithsonian, Alex Hurlichka, who really thought that. He thought that there hadn't been enough time for major cultures to develop in the New World, that they were basically had gotten there a few minutes before Europeans had, right? Like pretty much nothing. But in 1927 in Folsom, New Mexico, they found a Folsom point in association with extinct bison, which was a smoking gun or smoking spear, I guess, if you want to be cute about it. And then a few years later at Blackwater Jaw, they found another lancelet spear point, a Clovis point, in association with extinct mammoth bones. So, okay, we get a little bit older. And then starting in the 60s, people started proposing other sites like Tule Springs in Nevada. That site might be 24,000 years old. Maybe it's even 35,000 years old based on the site of Pedro Cruarda in Brazil. And then Calico Hills in California that's been being pretty much continuously excavated since like the 1970s. Some people said, hey, maybe the site's 100,000 years old. But as we started doing more zooming in and looking more carefully at the artifacts, at the context, were these things in good context? Are they really artifacts made by humans? And in fact, none of those sites have stood up to the test of time. So from the 1950s to the 1990s, there was this dominant paradigm that the first peoples arrived in the Americas about 13,000 years ago. And this was what I was taught in school. This is now known as the Clovis first / Icefree corridor model, which basically said this, that Clovis people carrying their distinctive technology crossed the Bering Land Bridge from Russia to Alaska. They passed through the Canadian Icefree corridor maybe 14,000 years ago. The traditional model said 13,000 years ago. And then they spread throughout North and South America by 13,000 years ago. This was the model of the peopling of the Americas. And when I entered graduate school, that was the model. So basically our job as Paleo-Indian archaeologists was to refine that, find more Clovis sites and talk more about how Clovis people lived and what they did. And that's what we really did for decades, right? So we defined what Clovis was. The radiocarbon dating of it at more than a dozen sites has shown that it falls into this time range, either 13,025 years ago to 12,675 years ago, or there's some people who think that there's a quote unquote long Clovis chronology that's about 13,200 years ago, so maybe about 200 years longer than that, and that it extends as long as 12,600 years ago. But regardless, Clovis dates to around 13,000 years ago, plus or minus a little bit. And it contains these artifacts that you've all probably seen. They're always in the shiny pages of artifact books and on shiny websites. People really love Clovis points, and any idiot, you give them 10 minutes with some artifacts and you show them a Clovis point, they can recognize a Clovis point, right? Like they're very distinctive. They're these fluted points you see there in that top right picture. We also have, in some places, people are making blades and blade cores. That's much more common in Texas than it is really anywhere else. We also have overshot flaking as the means to which they are making these points. And if you want me to talk about the technology, I can. However, now that we've done more dating, and those black dots on this map are the sites where Clovis has been directly dated. And by directly dated, I mean it's elephant bone in association with a Clovis point. Usually that's almost all of the dates that you see on that map. You also see that there's places where there are sites that are the same age, that 13,000 to 12,600 age range, that have material, cultural material that is not Clovis. It's not these overshot flakes. It's not fluted points. It's not blade cores or blades. There are sites in South America and in the northeastern United States and on coastal California that have radiocarbon dates that are that exact same time that are not Clovis material, that they're very distinctly different. Also, in the very few, very rarely preserved archaeological sites, aka underwater in the Osceola River, there's one other aspect that we think is part of Clovis technology. There are these bone and ivory projectile points, bone and ivory tools like awls and needles, and things like atlatl shaft straighteners, atlatl hooks, things like that. Almost all of those have been recovered from rivers in Florida. They are not known continent-wide, probably because most of the sites of the time period, the only thing we have is a few elephant bones, like their preservation's just not there. But that has led to, now that these radiocarbon dates of these 17 or 18 Clovis sites have come really clearly, and now that we have multiple dates from sites that are not Clovis, that we have technology that does not look anything like Clovis, and it dates through that same span as Clovis. And even more importantly, we have several sites in Alaska that have been directly dated, but they date to way younger than Clovis, like more than 1,000 years younger than Clovis. We haven't found any Clovis in Alaska or in Canada. That's like made us challenge some of the aspects of this. So maybe we think maybe we need to revisit what we think we know. So let me take you back to the slide I showed you at the beginning. So these are the three routes: the traditional route that, okay, through the Icefree corridor; the second route by the coast anytime after 17,000 years ago; and then the third route by boat from Europe. So the first thing I'm going to talk about is, where did they come from? there has been a lot of ancient DNA studies that have come out in the past 5 years, more than 40 of them, that have been trying to figure out the origins of both modern Native American peoples and ancient Native skeletons. Like, so skeletons that have been found in archaeological sites in the Americas, skeletons have been found in archaeological sites in the Old World. And then also modern populations, modern people everywhere in the world calculating their relatedness to each other. And this has been revolutionary to the field of archaeology. And if you can find somebody, you should have somebody give you an ancient DNA talk at some point, because it's really cool, everything they've been finding in this last 10, 15 years, and especially in the last 5 years. So they vary in a few different things. They vary in how many times they think the Americas were colonized, whether it was just once people came from the Old World and then came to the New World, or whether it was waves 2, 3 times. But all of them have a few different things that are in common, right? They all say that the DNA that contributed to both ancient Native Americans and modern Native Americans came from Asia, Southeast Asia and Northern Asia, and that there is no European contribution in these ancient DNA studies. And they all think that populations in the Old World split around 25,000 years ago to somewhere between 16,000 years ago. So there's a lot of squish in there, but nothing's older than 25,000 years ago, and nothing's really younger than about 16,000 years ago. And really interestingly, an article that came out last year found that the same thing happens with dog DNA, that the very first people in the New World probably brought their dogs with them because they're seeing the same genetic branching of the same clustering of Southeast Asian and Asian populations in dogs. And the splits happened at about the same time, about 20,000, 22,000 years ago for the first split, and then another split around 15,000 years ago. And so what that picture, that very complicated image that came from the Perry article is showing you is that if you follow the faint lines down, DNA splits between the dogs and humans happen at about the same time. So people are bringing their dogs with them, and that's like evidence that backs up what they're saying. So what the DNA evidence is telling us is that a European origin for the peopling of the Americas is extremely unlikely. If anyone came from Europe to the New World, they came and they hung out for a little while and they died out and didn't leave any descendants, right? And so they're not the answer for the major colonization of the New World. So there was a book that just came out, about 8 months ago by a woman named Jenny Rath, who's an ancient DNA person at the University of Kansas. And she said, okay, well, then these are our major contentious models, right? Okay, so maybe colonization happened a really long time ago, like 130,000 years ago, based on this one site, the Cerruti Mastodon site in California. Or more compellingly, people came around 15,000 years ago. The Icefree corridor model is still our strongest. Or the second model, the coastal route model by boat, right? So breaking that down. So I'm going to step back for a second and say, okay, the New World record can tell us some stuff, but what does the Old World record say, right? If the first people came here greater than 130,000 years ago, there had to be people in the Old World to get them there, right? They couldn't just magically teleport from Africa to the New World unless they were time travelers from the future or something. They had to have come from somewhere. So what we see is greater than 130,000 years ago, there are no accepted sites in all of Southeast Asia or Siberia. Nothing, like nothing at all. So that can't be the founding populations for the peopling of the Americas. The middle Paleolithic, there's Neanderthals, there's Homo denisova, and there's Homo sapiens. There's all these, there's like at least 3 different populations of hominids, which based on DNA evidence probably interbred with each other, which makes sense if you know anything about people. But they are just in the southern boundary, just very, very down, like on this map, it's all of the little white triangles that are clustered down in here, like barely into Siberia at all, like 5,000 miles from North America, right? Like just nowhere. So probably this is not the explanation. So our strongest candidates for the peopling of the Americas are these red and yellow sites that are spreading out across the entire spread of Siberia and Asia, right? Like we're getting some spread, but they're still mostly clustered. So during the Middle Upper Paleolithic, most of our sites are, oh, that moved over a little bit. Most of our sites are around Lake Baikal. They're still in the southern area, but there is this one bit of data right here, the Yana River sites, which are some of the coolest archaeological sites, both literally and metaphorically, you'll ever hear about. They date to around 32,000 to 30,000 years ago. And they were found by ivory miners on the Yana River, where they, way up here, basically these guys are, their neighbors are Santa and nobody else. They live farther up there than anybody else does permanently, where they have all of these ivory tools and these big, huge stone tools. They're made cups out of rhinoceros ivory. There's beads, there's all kinds of crazy stuff. And this stuff doesn't look unlike Clovis stuff, but it's 17,000 years older than Clovis. So maybe these guys are the people that were hanging out in the Arctic Circle and they came to the New World around 30,000 years ago. But we don't know where the sites are between 30,000 years ago and 13,000 years ago. Like what were they doing until we see Clovis sites everywhere on the Great Plains, right? So there's some big questions there. So what we do see is during the late Upper Paleolithic, an enormous expansion of humans. All these yellow dots on this map, they're all over. And they make these specialized toolkits, these bifacial cores that they use to make microblades. And I should have a scale on those. Those microblades are like the size of your fingernail, that they use to make these really cool artifacts. They take bones, they grind like slots in the sides of them, and then they use mastic to put the microblades into them. And every time a microblade breaks off, they basically heat it up, pull out the microblade, slot another one in, and hey presto, you've got a repaired tool. These tools experimentally have been shown to be super effective. The bones provide the bone points provide really good penetration, and then those microblades just lacerate the heck out of whatever they shoot. So they cause catastrophic blood loss, right? Like, so they're really effective hunting and killing weapon that is very repairable, which is great if you guys are living in a glacial world where you're not sure where you're going to find your next big source of toolstone, right? Like they're very clever weapons. But what they do not have, no fluted points at all. So, okay, great. We have a lot of sites 18,000 years ago to 11,000 years ago in the old world. What about in the new world? If our first colonization of the Americas is happening through the land bridge, we would expect a bunch of sites in Alaska because they would have had to walk through Alaska to get to the new world. Now, Alaska is not Florida. It's not just super easy to get everywhere. And I shouldn't even say Florida is. We got swamps everywhere. Alaska is not the Great Plains. You can't just walk anywhere and look for archaeology. There's a lot of complications with working there. But to this day, the oldest site we have are along basically a few major river drainages. And Swan Point is the oldest one. The oldest directly dated cultural component dates to about 14,200 years ago, pre-Clovis in age, to 13,800. And what it is the exact same material we have in the late Upper Paleolithic in Russia. The exact same material. In fact, some of the sites actually have raw materials that came from Asia. So like they are the same culture. We got these microblades, we got the bifaces, all of the same things. No fluted points at all, no Clovis, nothing that looks like Clovis. And the same site has cultural material that is starting to look more Clovis-like, but they date after Clovis. So if anything, it's probably cultural material that's coming back up the Icefree corridor once it melts away. It's actually probably late Paleo-Indian Great Plains people following bison back up through the Albertan plains into, interior Alaska. So what's that showing us? That probably the Cerruti stuff is not very tenable, and there's a whole bunch of geoarchaeological reasons why we're pretty skeptical about Cerruti anyway. But basically, there was nobody around 130,000 years ago within 10,000 miles to get to the New World. So those are probably not hominid sites. They're probably not cultural. So instead, we're left with, again, Icefree corridor around 15,000 years ago or 17,000 years ago by boat. And this is the distribution of Clovis points, just to show you again. Nearly all of them are found in North America. These are the dated Clovis sites that we have so far, and then the East Wenatchee cache, in case you know about that. And that makes us think, if these are all found there, they invented south of these sheets. And if so, what could they have come from? So there's this handful of sites that date in the 15,000 to 17,000 year range that have been proposed in the last 15, 20 years to be pre-Clovis sites, right? They all contain artifacts that are similar to, but not the same as Clovis. If they had Clovis material, they wouldn't be pre-Clovis sites. Clovis would just date to a longer period of time. So they have bifaces, they have little blades, or they have big blades. They have osseous material, like people are using mammoths and mastodons, similar to what Clovis people do. They all are older than the Clovis sites. However, none of these is accepted by all scientists, and I will bore you to death if you all with discussion of all of them. I'm going to spend a little bit of time talking to you about the Page-Ladson site. So no, only one of these sites is on the coast. If I want to the first peopling of the Americas happen on the coast, I'm going to have to make a really compelling argument for you. So I'm going to start with Page-Ladson and work out from there. Because the underwater is important for a lot of reasons. So underwater sites can give us the advantage of preservation. This is a little bit of Archaeology 100, and I'm sure it's so basic, it's really obvious to all of you, but archaeological sites are made by people. If they're not made by people, it's not an archaeological site. It's a place where some artifacts got dumped, right? But the preservation of those sites is due to both cultural and natural processes, right? As soon as people leave stuff behind, the coyotes come and they drag away the carcasses, the rats and the mice, they eat the bones, trees fall and tear things apart, everything messes stuff up. So basically, most sites do not get preserved, but the best preserved sites are the ones that get buried rapidly with gentle burial, that are in places with no air or light, and if they're in constant environments. So underwater sites and stable settings can be some of our best preserved. This is a picture of your typical terrestrial site in Florida, right? It's actually one that was a mound that somebody dug a pothole in, and they took all of the nice artifacts and they left this handful of cores on the surface, right? That is what our typical site in Florida looks like. And almost all sites, almost all underwater sites were drowned after they were created. This shouldn't be a remarkable statement. People don't live underwater. They aren't making their sites and then underwater in most cases. Instead, they're doing their stuff on land, and sea level rises, lakes rise, they get drowned, they get buried, they get covered. Except in Florida, there's some really early cemeteries where people did on purpose bury their dead underwater in shallow ponds. And I think that has something to do with the way Florida's coastlines drowned when people were first here. They saw the oceans coming, and that ended up having some important cultural significance to them. So this is what Florida's coast looked like. But this is what the swamps where I work look like. These are these really low energy environments. And in these low energy environments, you can get things like this. This is one of the baby mastodon bones from the Page-Ladson site, what it looked like underwater as we were excavating it, and everything that's surrounding it. That is a mixture of chewed mastodon dung. As far as I can tell, mastodons don't digest anything that they eat. It just goes straight through them. It's a lot of little sticks. It's great skins. It's great seeds. It's little coils of grapevines. There's a whole bunch of acacia. There's thorns. There's all kinds of stuff in there. And then the bone is so perfectly preserved, it's still bone. And you bring it up 14,500 years later. But offshore, in these high energy environments, you can still get decently preserved sites. This is an early archaic Kirk Point being used by a sea urchin as part of its armor. It's one of my favorite pictures of an archaeological material ever in the history of the world. This was amongst a big site that Michael Fott and some colleagues explored in the early 90s, where they found dozens and dozens of early archaic artifacts scattered on the seafloor. Sometimes they were buried, sometimes they were exposed, depending on what the hurricanes were doing, but it still told them a lot. So let me talk to you a little bit about why this matters. So Florida, just to put it in a context, there's 573 recorded sites, all of these white dots on the map with artifact styles that date to the late Paleoindian and early archaic periods. And you can see how much of the landscape has been lost. I have a bunch of coastlines up there in that rainbow colored map showing you that even by 8,000 years ago, coastlines were way different than they are today. So this landscape, this data set's really biased. The offshore material I'm going to tell you about, or the underwater material I'm going to be telling you about in a second here, it's really telling you about inland and upland peoples. The Osceola River Basin here, where I'm going to talk to you about, has this huge cluster of sites, and I'm going to talk to you about why in just a second. It's because of the geology. It's because of the underwater preservation. So this is the Osceola Wassissa drainage basin. It does go up into Georgia, but I just have archaeological data from the Florida side. So you're getting the Florida bit of it there. All of the yellow dots on the map have Paleoindian or early archaic site at it, or diagnostic at the very least. And every artifact style that dates to prior to 9,000 years ago, everything that's older than 9,000 years ago in the Southeast, there's an example of it known from Florida, including this mastodon at the bottom here, known as Priscilla, Queen of the Osceola. It's a male mastodon whose skeleton you can see at the Florida Museum of Natural History if you're ever in Gainesville. It was excavated in the 1970s by an avocational guy who did a really great job with it. So these underwater preservation at these sites can really tell us a lot. And here's where Page-Ladson is. Page-Ladson was excavated in the 80s and 90s by a joint team of paleontologists and archaeologists, David Webb at the Florida Museum and Jim Dunbar, who is at the state of Florida. And they found this mastodon tusk with these cut marks. They found this handful of stone tools and this layer that was about 30 feet under the water and about 15 feet under sediment in the bottom of this river, right? The site was discovered by this Vietnam vet, Buddy Page, who was basically what SEALs would be before SEALs existed in Vietnam. So he had to do a lot of hard things. And one of his ways of coping once he got back to the States was he spent a lot of time in the bottom of a really dark river by himself. And he found a whole bunch of artifacts and a whole bunch of bone that he brought to David Webb and Jim Dunbar and said, hey, I think you have this really cool site. So they spent over a decade excavating at Page-Ladson. They defined the stratigraphy you see there in this area where the yellow was excavated. And what they found was that these things dated to about 14,400 years ago. So it was a pre-Clovis site. They published their work and everybody was like, sure, whatever. Because when they published it, it was during a time period where there was no questioning that Clovis were the first people. So obviously there was something wrong with the site. Were these cut marks actually human made on this bone, or was it elephant feet stomping around on it? Were the artifacts in place, or were they messed around? Or were they even real? So if you'll look at it, those break down in the same critiques I said that Vance Haynes laid down. Datable stratigraphy, definite artifacts, and association between the artifacts and the stratigraphy. They also found these artifacts at the site. They dubbed Page-Ladson points. They were all, well, these ones were from the site. These were ones from a nearby site where basically they were sitting loose on the bottom of the river. And so they said, hey, these are probably the artifacts that were used to kill the Mastodon, whose cut marks we see there, but nobody really knows. So basically they published their book in 2006, but they've been talking about the site for a dozen years before that. And everybody kind of ignored it. Nobody really cited it. They just were like, okay, this is crazy stuff going on. Is this video playing for you guys on your screens, or do I need to pull it off and show it on the other stuff? So in 2012, we came back and started working at the site again. We had two major questions. Is there really an older than Clovis component at the site? And if so, how were these Paleo-Indians living at the site? So this video is basically just showing us our setup for our fieldwork. You can see what the river's like. It's a tannic river, so it's not full of mud the way most rivers are. It's just dark like iced tea. It's tannins that have come from the leaves that the water is running over. We excavated in square units, just like we do on land. We used trowels, we used tape measures, we used lasers to control our depth. The only difference is our dirt goes up a dredge to the surface on those screens that you saw sitting there. So you don't have to carry buckets. Your dirt just magically goes away. Your only job underwater is to dig. We started in 2012. We had a field season then, and in 2013 we came back. And what we found laying down there in that deep layer was this stone knife sitting there in this Mastodon digesta. And this is just kind of overview of the whole thing. And Mike Waters, who is my dissertation advisor, holding up that knife for y'all to see. So we were able to answer that question. What we did is we did a whole bunch of excavation, 10 cores, a bunch of column samples, a bunch of various geological samples, 47 different excavation units. What we did was the red and the blue that you see on this map, and a whole bunch of shovel test pits on land. And we found that there are definitely 3 underwater cultural components at the site. The oldest one, this biface that you saw the picture of, down there where there were a whole bunch of things that we were able to radiocarbon date. We collected 30 samples from right around it, and then more than 130 from the strata of the site altogether. And then that Bolin component I showed you some pictures of earlier, and then another one that has not had any diagnostics yet, but has a whole bunch of bone tools that is younger than the Bolin component. But the oldest one is the one that's most famous and most interesting for our big picture understanding of the peopling of the Americas. So what we've found since then, we've been digging off and on about every other or every third year since then, and we're planning to go back this summer. We found 12 unambiguous artifacts. What you see here is a map of all of the bones, mostly elephant bones, and all of those artifacts as they're distributed related to those bones from our excavations from 2013 onwards. One of those is a biface, one's a worked flake, and then all the others are just flakes. And they're all made of local chert from the Swanee River chert clusters, but not from within the sinkhole. So they all had to come from somewhere else. They weren't skittered in by elephants on their feet as they were sliding down into the sinkhole to get a drink of water. They came from elsewhere. And we have mammoth bones, camel bones, paleolama bones, and bison bones down in this layer. So these are mostly the paleolama bones. These are bits of that baby mastodon you saw a picture of earlier. And then there's just a couple bison bones scattered in there as well. So what it looks like we have It's this area where there's not a lot of bones, this area where there's kind of a lot of bones, and where there's kind of a lot of bones, there's also all of the artifacts. So that's arguably good evidence those bones and those artifacts are associated with one another. And all of the radiocarbon dates also help show us some similar stuff. So we were able to do a good cross section of the site of all the geological deposits. You can see, so 1 meter down and 2 meters wide. So it's not that steep sided. It's twice as wide as it is on that picture. This is just shortened to show you. And all the radiocarbon dates that are showing you all the different strata. The yellow line up here is showing you how that fits in a real space. But more importantly, all of these dates where that biface was found are in order. They're showing us the stratigraphy is as old as we think it is. And these are the radiocarbon dates. They're not the calibrated ages. What they calibrate to is about 14,500 years ago. So those came from right about there. That's just zoomed in, so it's a little bit easier for you guys to see and read if you want to. And pretty much what they're showing us, these purple ages are the ones that were taken from on top of and on the bottom of that biface as we pulled it up. So, you know, make sure it wasn't in some weird hole a badger dug straight down and put the artifact in the bottom of it and then left it behind or something. Those dates are the same as the dates that are around them. And we also looked at that cut mark tusk a little more. We didn't find any more tusks. We found lots of pieces of baby mastodon. This mastodon that made this tusk was a big old bull, probably about 50 years old. But what we found is these cut marks. This is zoomed into right there. There's a lot more of them than they originally reported. There's like some right there, but there's some along this whole thing. And Dan Fisher, who's a guy, one of the few Americans who's really butchered elephants in this day and age, what he thinks has happened is modern day elephant tusks have this really strong ligament that runs along the tusk that holds them from going like this, because elephants use their tusks for a lot of stuff. But if you cut through the tissue right there where it's held into your jaw, you can slice that really easily, and then you can just screw the tusk out of an elephant's jaw. Like that's what's holding it in place. You can just pull it really easily if you cut that. So what he thinks happened is people basically hacked into the jaw right there, cut that tendon, or sorry, ligament, and then pulled the tusk out. So you might very reasonably ask, okay, why did they do that? Why did they pull out the tusk and then leave it at the bottom of a pond 14,500 years ago? But what he thinks happened is inside that tusk cavity, there's about 10 pounds of super fatty, super rich meat. So they might have just been going after that, or they might have taken both tusks out, realized they only needed one to make their ivory tools, and left the other one in the pond so they could come back for it later, and then they just never came back for it later. So what Page-Ladson has is skeletons or artifacts, in this case artifacts that are clearly made by people. Nobody's going to say that biface isn't made by people. It's found in undisturbed geological deposits. We've got all of these radiocarbon dates and all these strata that show that it is. We've done micromorphology, all kinds of crazy stuff. And we know that the stratigraphy is associated with those artifacts and that it's datable to about 14,550 years ago. So that tells us some really important stuff. First of all, Page-Ladson was super far inland 14,550 years ago, right? Like it was this far, it was more than 300 miles from the shore. It was like this inland, upland, tiny pond in the middle of an open, dry savanna where people were probably moving from isolated waterhole to isolated waterhole, maybe because they knew where they were, maybe because they were following elephants. But what this is showing me is that these folks were inland foragers. They were people who are well used to living on this prairie savanna environment. And they were, Page-Ladson was this really small, super unimportant locale. It was just in the middle of nowhere. It's not like on the edge of a bluff. It's not like you follow a major river down and you hit this great outcrop of stone. It's not like Topper, like the first place you would be on a landscape. It is a nothing place. So to me, that means people were everywhere on the landscape if they had found Page-Ladson by 14,500 years ago. And it's not an isolated site in Florida, though there's not very many sites of this time period. There are 3 sites you can see. So the 2 map, there's Page-Ladson in a site that's about a half-mile away from Page-Ladson that has these Page-Ladson points. And then another site within the same quarry cluster about 25 miles away that have these artifacts. So there's not many, but there's a few. So we're hoping to look for more. And these Page-Ladson points might be telling us about what these first people were using as their hunting tools. But I want to remind you, those have only been found loose. They haven't been found in stratigraphy. This is the artifact from which that is from stratigraphy. And it's just a biface. It's like a broken knife blade. You all have found 100 of them in your careers as archaeologists or avocational archaeologists, right? You found them everywhere. So what Page-Ladson tells us is that people were well established by Clovis. By 14,500 years ago, they're everywhere on the landscape. So by 13,000 years ago, they were probably really everywhere. The inland and the upland portions of the continent were really occupied pretty much everywhere, probably, if they found Page-Ladson, because it's such a nothing site, except for the fact that it's able to be dated. That's what's important about it. Such good organic preservation, so we could get those 130 dates. And that has some really big implications. So recent geological data have shown us that the Icefree corridor probably wasn't open until about 12,600 years ago. Remember, Clovis ends at 12,600 years ago. Ancient DNA is showing that basically there's no DNA prior to 12,600 years ago. And then at 12.6, we got rabbits and bison, and then like marmots and things like that. And you get more and more and more DNA. And the Icefree corridor becomes this awesome place by about 12,400 years ago. But there's really nothing before that. So this is when people would have been doing all kinds of stuff in the plains of Alberta, probably. And so also people did some dating of rocks. I kid you not, this cosmic dating thing, it's like this magic thing. And it's showing us that the Icefree corridor also was not free until about 12,600 years ago, based on dating the rocks in the corridor. But on the coast, by 17,000 years ago, those rocks were exposed. And so the coast would have been free. Now, there's been another guy, Ben Potter, who doesn't buy that. And so this is a debated discussion, but it is, it's actively being researched by people right now. That leads us down to probably the coast, according to what I think the data is most strongly supporting it. But I'm leaving the Icefree corridor possibility as a question mark, which leads us to, okay, coast, what does that mean? There's been a couple of articles that have published lately that say, okay, coastal people might have been island hopping from Japan, or they might have been island hopping from along the entire Beringian coast. And we're not talking like 3-masted schooners. We're talking like hide boats probably, and probably people were never out of sight of land. They were bopping from pocket beach to pocket beach to pocket beach, which they would have been probably doing because the seals and the sea lions and the walruses would have been living on those, breeding, having babies, all of that sort of thing. So they've been these delicious things to come hunt. And then by about 17,000 years ago, there's pretty good data that the salmon were starting to run the rivers in the Northwest coast in Alaska. So this guy, Mark Sutton, published an article a couple of years ago that he thinks that explains our early archaeology. Basically, people are coming to where the big rivers are, and they're following the salmon runs, and they're bouncing from salmon run to salmon run to salmon run, which would really quickly lead you down the coast and colonizing the major river valleys, but maybe not a lot of the space in between, because why would you? You're living in the land of milk and honey, or the land of salmon and walrus, so you don't need to expand inwards of that for at least a while. So what I think that means, I and some other folks, I am not come up with this all on my own, is that around 15 or 16,000 years ago, the first populations in the Americas are coming along the coast and then spreading inland south of the ice sheets. They might have been using these artifacts that I haven't talked to you about a lot, the Western stemmed artifacts, these unfluted landslip points, but they also, this is probably their first stuff. And then Clovis people came from those, or there was a migration after about 14,000 years ago into the New World, and we just haven't found any Clovis points in the Old World yet. In short, in summary, Clovis first really does not fit all of the data that we have anymore. So migration from Northeast Asia via boats was probably what happened first. And then people spread via land. But that doesn't mean we understand everything that's happening. We need to figure out how folks are getting from the coast, the Northwest coast, to Page-Ladson in the interior by 14,500 years ago. Again, Page-Ladson isn't a coastal site, so we don't know everything yet, which is important because that's job security for me. We still have a lot of questions to ask and answer. We don't have a lot of coastal early sites, so maybe there is interior sites that we haven't discovered yet. We only have a few data points. There's a lot to know, and so this is a really exciting area of research for these upcoming years. We have to find more sites. We need to do more research, and we need to come together, basically keep doing our paleoenvironmental research to find out where sites might have preserved and go find those sites. Okay, so that's all I have. I guess I went a couple minutes long. I apologize. So if you have any questions, I'm more than happy to answer them. But if I talk too much and you're all asleep, I hope I gave you a good nap, whichever way.
Okay, who's got questions?
You turn the lights on at all?
Yeah, let's turn the lights on.
Can she see me?
No, she can't see me yet.
Okay.
I can kind of see you mistily in the dark.
Oh. Okay. All right, there I am. First thing I'm going to say is I really appreciate you being here and give us an excellent presentation. And next thing we'll do is ask if anyone has any questions of Dr. Halligan. Please ask away. Either or on the light. Sorry about that.
I'm sorry about the lights.
Yeah.
It's confusing.
Yeah. There we go. Okay, that's good. All right. Anyone have any questions at this time?
I had a question about the ice-free corridor. Is it or isn't it? And you have worked on that answer way before I got to it. So thank you for telling us more about that. I've sort of felt like it was maybe not really real. I'm not convinced yet that it is or was, but I think you've done a good job of explaining what we know about it and what we don't know about it. Thank you.
So we do, yeah, we absolutely know it was real by about 12,600 years ago. There's really good evidence based on bison DNA from herds that are in Alberta, herds that are south of the ice sheets, and herds that are in Alaska, and ancient skeletons that are showing that like basically Great Plains bison are ending up in Alaska by about 12,600 years ago. And that's how elk actually came from the Old World into the New World during the end of the Ice Age as well. And so there is an ice-free corridor, but it definitely doesn't seem right now like no data is showing that it was open early enough. I like to, say, okay, well, the data shows that there were all these glacial lakes by about 14,000 years ago. And a lot of the male archaeologists I work with are like, yeah, so no big deal. They just got in their boats and they kayaked through them. And I'm like, but there was no food and nobody knows there's anything on the other side of it. So maybe a bunch of young guys were doing that, but you're not telling me that pregnant women and old women are getting in these things to be like, sure, hon, I believe you. There's going to be a continent on the other side without some real data. They'd be like, yeah, no way, honey.
Yep.
Thank you.
Mhm.
Anybody else?
The only thing I really wanted to say was that you have convinced me that the migration, part of the migration, at least anyway, certainly came by boat. And one thing I was wondering about too is I had read recently about the water archaeology or whatever. I mean, is it still are you still getting pushback from whatever, from academia about archaeology underwater like that? That you can't tell the layers of sediments, I mean, whatever it is.
You would be surprised at how much you do get pushback on it. And it's weird because I can bring my sediment cores and be like, see, here's a layer, like layer 1, layer 2, layer 3. And they'll be like, yeah, I can see those layers. How can you see it underwater? It's like, well, how can you see it when you're digging a hole on land? Like half the time you find a feature because, you know, the dirt's just a little softer and you look around and, or, you know, so archaeology is, you know, as much of a magic and art as it is a science in some ways, but underwater, I have very clear, this is a dark layer, this is a bright layer, and they're touched like this, like they're completely different colors. Like you can't get clearer than that. But yes, I do, but I don't think it's actually so much because people don't think that we see the layers. It's because what we're finding is something that they don't want to see, right? I think there's some of that.
Oh.
Right, especially when it's all been written in stone for years.
Right. Exactly. Which is too bad. You'd think everybody would want everything to be questioned because, like I say, that's job security for all of us. If everybody's known what the answer was for 50 years, why should NSF give us any grant money to look for these sites if all the answers are known?
Yeah, thank you very much.
Thank you. Thanks for coming.
Anybody else? It's Dr. Halligan. I have one quick question for you. I appreciate you tying all that together. And you'd mentioned the coastal to inland routes about how they got down the coast of, say, California and Baja California. What are your thoughts on how they actually got from there to Florida?
So I don't know if you guys know David Anderson, but he does a lot of work up in kind of your neck of the woods, so you may have run into him. He gave this talk a couple of years ago that I actually thought made a lot of sense. So once you get down to Baja California, you're like on the coast there and it's pretty dry, but you can pretty easily get to those rivers once you're south of the Rocky Mountains that would like lead you across into the Gulf of Mexico. It's also possible you're following the coast along and then you end up in Panama and you kind of go see, okay, what's on the top of the mountains? You go down the other side. Oh, hey, there's a whole bunch over there. But we honestly don't know yet. I think though it's going to involve some kind of coming to the mouths of rivers, following those rivers into other rivers and following watersheds. Like I do think that is going to be the answer, even though, as I said, Page-Ladson was not part of a river at the time. It was an isolated sinkhole. So it was one of the last places people found. They probably found it by following elephants who are looking for water, you know.
Thank you very much. I appreciate that. Anyone else have any other questions? All right. Thank you, Dr. Halligan. We appreciate your time very much and looking forward to hearing from you again sometime.
Yeah, thank you so much for having me. It was a great honor to get to speak to you all. I hope I entertained you enough that the tips didn't put you too much to sleep. Thank you.
Oh, no, man, that's awesome. Thank you.
All right, thank you. Goodbye.
Goodbye.